Hi, this is David Voss, CCIE 11372, and in this video, we're going to cover routing protocol concepts to introduce you to routing protocols for your CCDA exam.
Cisco wants you to be able to identify the attributes of routing protocols so that you can make the correct design decisions. The fundamental question is, which routing protocol should you use? When answering that question, you must keep in mind the following characteristics of routing protocols. And Cisco wants you to remember all of these. First is scalability. How large is your network now? How large will it become? This is important because there are versions of RIP, or actually all versions of RIP, have a maximum hop count of 15 routers. OSPF and EIGRP scale much better, and BGP is the primary routing protocol used on the internet, so obviously it scales very well, and many companies in fact use BGP internally for that reason. Vendor interoperability. Will you be using all Cisco routers on your network, or will it be a blend of Cisco and non-Cisco? Why is that important? Well, RIP and OSPF work fine regardless of vendor, and now even Cisco has taken steps to ensure EIGRP can be used by any networking vendor. The question is, do they support it? RIP and OSPF and BGP most likely, EIGRP maybe or maybe not by non-Cisco vendors. IT staff's familiarity with the protocol. You and the IT staff at your company might be much more familiar with one routing protocol over another. I worked at a company where we had an internal debate over EIGRP versus OSPF. And the tipping point for the conversation was, what protocol do the engineers already know or want to learn better? It was OSPF. And therefore that's what we went with as far as our design decision. That was the tipping point. You will have the same debates internally and should be prepared for this in your decision-making process. Speed of convergence. A benefit of dynamic routing protocols over static routes is the ability for dynamic routing protocols to reroute around network failures. When this failure occurs, the network recalculates and reaches a steady state condition. This is called the state of being a converged network. The amount of time for the failover to occur is called the convergence time. Now, some routing protocols have faster convergence times than others. This is important because when a network is not in a steady state, data can be dropped or looped within the network. You should know that because RIP and BGP might take up to a few minutes to converge. By contrast, OSPF and EIGRP converge in just a few seconds. The capability to perform summarization. Large enterprise networks can have routing tables with many route entries, and network summarization allows multiple routes to then be summarized into a single route advertisement. So it reduces the number of entries in a router's routing table. That eats up less memory, and also CPU, because it reduces the number of network advertisements that need to be sent. And that can obviously increase convergence time as well. Here's a perfect example. Let's say we're looking at the routing table of a core router, and it knows about all the branch offices. And let's say there are 255 branch offices, and each are allotted a /24, and they're assigned a 192.168 x.0/24 network. Now, sure, the core router has individual entries for all of these routes and knows how to reach all of them through separate interfaces or tunnels. But all of these routes do not need to be passed individually throughout the network onto a neighbor through a route advertisement. They can be summarized using one summary route, 192.168.00/16. So as you can see, using summarization, we're saving a lot of memory and CPU by simply summarizing all of these routes into one single route. Interior or exterior routing. A key term you need to understand is AS, which stands for Autonomous System, and this is a network under a single administrative control. A network might be a single AS, and when it connects to, let's say, another network, let's say an internet service provider, then it's connecting to a separate AS. When you're selecting a routing protocol, you need to determine, is it running inside your network, or will you be running it with somebody outside of your network? To answer the question as to what routing protocol you should run, you need to understand if you need an IGP, an interior gateway protocol, or a EGP, an exterior gateway protocol. An IGP exchanges routes between routers in a single AS. common IGPs are EIGRP or OSPF, and then RIP and ISIS are also used, but not as much. Today, the only EGP in use is BGP. But please note that BGP is sometimes also used as an interior gateway protocol as well. There are two types of routing protocols. The first type is distance vector. Distance vector routing protocols send a full copy of the router's routing table to directly attached neighbors. Now, obviously this is not very efficient because it's sending information to a neighbor even if the neighbor already has that information. This can lead to slower convergence time. With slow convergence time, you then can introduce routing loops. The routing protocols that are considered distance vector are RIP and EIGRP. There are two mechanisms that you can use to deal with routing loops that Cisco wants you to know. The first is split horizon. This prevents a route learned on an interface from being advertised back out that same interface. I'll show you a diagram in a minute so this makes more sense. And then there's poison reverse, which causes a route received on one interface to then be advertised out the same interface with an infinite metric so that nobody actually wants to use it. But let's go ahead and take a look at the diagram so we can better understand the issue with routing loops and distance vector routing protocols, and then what we can do about it with split horizon or poison reverse. As you can see here, we have a basic point-to-point network, router 1 connecting to router 2 over serial interface, and then a network 192.168.1.0/24, which is then advertised out serial 0 over to router 1. Router 1 then learns that route and places it in its routing table, as you can see here, with a metric of 1 hop. Now, what if Ethernet 0 on router 2 were to go down and the network were no longer available? The problem with distance vector routing is that router 1 is going to send its full routing table over to router 2. Well, router 2 does not know about 192.168.1.0 anymore, so when it receives the subnet advertisement from router 1 of 192.168.1.0, it's going to accept it and place it in its routing table with a metric of 2. And this is where we introduce routing loops. Router 2 will then forward traffic over to router 1. Router 1 thinks it can reach that network via router 2, and traffic will then loop between the two routers. This obviously is not ideal. Now, you've already learned about the two solutions to deal with that, and you'll need to know it for your CCNP exam. Split horizon will prevent a route learned on an interface from being advertised back out that same interface, and then poison reverse, which causes a route received on one interface to be advertised out that same interface with an infinite metric. The next type of routing protocol you need to be aware of is the link state routing protocol. Routers send link state advertisements, or LSA, to advertise the networks they know how to reach. So they don't send the full routing table, just the networks they know how to reach, and only when there is a change in the topology. They only exchange full routing information when two routers initially form their adjacency, but from there on out, it's on a need-to-know basis. The routing protocols that are link state routing protocols are OSPF and ISIS. And the final type of routing protocol you need to know is path vector. BGP is path vector, and it includes information not just about the neighbor, but the exact path that packets take to reach a specific destination network. So when you do look at BGP advertisements, you can see exactly over what autonomous systems that traffic is flowing over. So you've learned about the role of routing in an enterprise network and the different layers of enterprise network design. And then you learn the basic characteristics of routing protocols, which is really going to help you as you solidify your foundation and now you move forward in your CCNP studies. I'm sure you're going to do great and continue on with the video series, and good luck to you in your studies.